Check the time. Oh, it's Solana o'clock. Time for another tutorial. Today, we're gonna talk about Sysvars. Specifically, we're gonna have a look at the clock Sysvar and how we can work with time in the Solana cluster. Now, maybe let's start with doing an introduction to Solana Sysvars. Because remember, programs on Solana do not store any state. They can't have any variables unless they're static, but then they're not variable, right? They can only have constants. So for everything that changes, we need accounts on Solana. And then there are variables that don't belong to one specific program, but are relevant for the entire Solana cluster. Like, for instance, which epoch we're in, which slot we're on, the recent slot hashes, recent block hashes, those sort of things. And a program might want to access that. And the way we can do that is by using Solana Sysvars. So system variables. Is var actually variable? I think so. And those variables can be accessed through Sysvar accounts. Because again, a Solana program, to read some variable data, it reads from accounts. So the way Solana set up their Sysvars is also just to have them be accounts that can be read. So they are read-only, you cannot write to those accounts, but you can read from them. And as they are variables, you will get different results every time you read them. Even though you don't write to those accounts, but the system, the Solana cluster, writes to those. Or the validators provide it based on their state or something like that. You could say that it's a hack, where I basically provide the data the program wants inside an account that doesn't actually really live in the state. Those Sysvar accounts, they're not actually persisted on the blockchain per se, but at the point when they are read, they have a specific and deterministic value. Because the validators then obviously also vote on that. They make sure that the Sysvars were correctly filled, or whatever you want to say. So it's not that those Sysvars are constantly written onto the blockchain like it would be done with like an Oracle account or something, but they contain the correct values when they are read by a program. It's just a way of setting it up such that programs always deal with accounts, and those Sysvars can then be dealt with like an account, because they kinda are, but they also kinda aren't. But let's not talk about it too much. Let's actually have a look at it. Or maybe we talk about it a little more, because I want to make a clear distinction between two kinds of Sysvars. But for that, let's pull up the docs. Sysvar cluster data. Solana exposes a variety of cluster state data to programs via Sysvar accounts. These accounts are populated at known addresses. So like the system program is a known address, or the compute budget program is like a known address. It's the same with those Sysvars. Those are just addresses that are defined. Somewhere those addresses are hard-coded. So there are two ways for a program to access a Sysvar. That's what I want to get into. First way is to use the get function. For instance, clock get, which gives us the clock Sysvar. But note that only 4 of the Sysvars actually support that. The clock, the epoch schedule, the fees, and the rent. For all others, we need to go the second way, which is to pass in the Sysvar to the program. We have done that before, for instance, with the instruction Sysvar or the slot hashes in recent videos. So you basically just pass those addresses in the list of accounts to the instruction as you would with any other account, and then you can read it by getting the account info and then getting the specific Sysvar from that account info. First method is more efficient, so if you can do it with the get, I recommend that you do it that way for those 4, but some just don't support that. The instructions, for instance, or the recent block hashes. You can't say Sysvar instructions get. Doesn't work with a get. This account address actually needs to be added to the keys of the instruction. So it must be already defined in the transaction. Now I can't be 100% sure why that is. I imagine it could be for security purposes, that not every program can just read the instructions or the block hashes without the user actually signing that. Because again, if you need to put it in the transaction, then at the point of signing, you can check which accounts there are and you see, oh, the instructions are there. Maybe I don't want that, right? Like giving permission that the instructions are read, kind of. So it could be a security thing, but it could also be just an implementation kind of a thing, that this Sysvar is only populated for the execution of an instruction or of a transaction if it actually contains that Sysvar, because if that Sysvar is not present, then I don't need to populate that account. If nobody wants to read the recent block hashes, then the validator doesn't need to write them into that account for reading. It doesn't need to allocate that memory. Maybe. I'm not sure. So it could have more reasons. But anyway, that's why for some of them, we need to specify them actually in the accounts that we want to read from, and others, clock, epoch fees, and rent, they are always available, even if I don't have any accounts defined in my transaction. So that's the theory. Cool. But what do we do then with those Sysvars? Well, obviously we can then read from it, and each of the Sysvars has a different layout. You can check them out in the docs. You'll always find this struct where you see what data it contains, and you'll also get some description for it. We have already worked with the instructions and with recent block hashes and recent slot hashes. So again, check out those videos where we worked with them. Today, I want to focus on the clock Sysvar, because I've never really worked with that. And working with time on the Solana cluster can actually be quite helpful. And I imagine that there are a lot of use cases for that. Whereas for the others, like the epoch schedule, the fees and the rent, I judge they are less important because, well, first of all, rent is static and is not even deducted anymore because every account needs to be rent exempt. Fees, well, contains the fee calculator for the current slot. But that is also static for now. So gives us a fee calculator. The fee calculator just gives us the Lamperts per signature, which currently is always just 5K. So it hasn't changed so far, and I don't see that it changes in the future. And if it does, then it might become relevant. But for now, this is not particularly interesting. Neither is the rent with a rental rate. We have the Lamperts per byte year and the exemption threshold. Amount of time in years a balance must include for rent for the account to be rent exempt. That is currently 2 years. And then we see how much is burned. But again, this is not even done anymore because all of the accounts need to be rent exempt. Wait, is it already 2 years since we said all of them needs to be rent exempt? Probably not. So it is still done for some accounts potentially. But soon this will be pretty much relevant. Well, not quite relevant because we still need those values to calculate rent exemption, but I think they have also never changed, same as the fee schedule. Let's not go into that too much. Slot hashes, slot history, and then we also have the stake history where we see the activations and deactivations. So just so you know what Sysvars there are, that's them. And today we focus on clock because I like to focus on clock. Good that this text allows for lowercase l's. Otherwise, I might like it even more. I want to see your clock. Okay, Andy, let's talk more action. Let's go. Should we do anchor program or should we go native for once again? Nah, let's do anchor. Easier to test with playground. Gimme a program ID. I'm gonna grant myself one. Okay, I choose this one. Yeah, that's how I spend most of my time, finding nice addresses. So, building successful. Amazing. Right. So, we have an empty program that tells us that it's Solana o'clock. Great. Maybe I rename this to clock time. Now, time to learn something. What can we learn? Well, how to access the clock Sysvar. And we already said it's one of the 4 special ones that I don't need to declare as an account, so I can just get it by saying clock get. Now clock I need to import. There we we go. That is an account info. I mean, I love the Rust analyzer, but it's a bit weird here. We're just gonna save that as our clock. Well, I guess Playground just isn't aware of those packages. Screw it. We pretend that I could just access the slot. Let's see if I could do that, which should give me a slot. Okay, great. It's a U64. Great. That helps. Some number of ticks long. Makes sense. The unit of time given to a leader for encoding a block. So the slot is the time that a leader has to build the block. So slot and block time is the same, but a slot can contain a block, but doesn't have to. If the leader decides to not build a block, or can't because it's offline, or messes up in some other way, then there might not be a block. That's why it's also nicer to count slots for time than it is to count blocks. So let's just say that's a U64. Oh, it is a bit annoying, this strange lock. No, it's clock, but you write that in there. I was a fan of Playground adding the Rust analyzer. Maybe I take it back. And then we just say we're in slot and write our slot. Let's see if that works. Clock doesn't have a slot. No field slot on type. So we have a result for an anchor preload clock or a program error. So what we need to do, well, what do we do with an result? If we don't manage to get the clock, then we get this error. And if we do, then we get the clock. So we can just say, well, if there is an error, put it into this result, right? Make the program error go 1 up. If I can't access the clock, I'll just fail the instruction. So this question mark should fix that. There we go, fixed it. And I can even apparently access .slot. Cool. Deploy. So, oh, that was the update. Sorry, I didn't execute it yet. Let's test that. Nice. And we see it's Solana o'clock and we're in slot. What is that? 245 million. DevNet already has almost 250 million slots. With a block time, or with a slot time of 400 milliseconds, that would be that many seconds by 360. What? That can't be. I made a mistake somewhere. It can't have run for 74 years. Let's try that again. What am I doing wrong? Here we see it again, the difference between slots and block height. Same order of magnitude, but not all slots contain a block. That's why block height is a little lower. So we missed about 10 million slots. On DevNet, that is. Let's check for mainnet. There we have similar values and we just reached the 200 million blocks and 18 million slots were not producing a block. That's slots. Every program on Solana can easily access which slot it's on. Basically, you get the clock and then you get the slot from the clock. Easy. And the slot is something that is really clear and well defined. There's no debate about which slot we're in. It's pretty clear. We're in that slot. This is the leader. Let's go. Other information that we have in the clock Sysvar is the epoch or epic, depending on your pronunciation. Some say that, some say that. I personally prefer epoch because epic sounds too epic. This is epic. And I want to use that word for saying this is pretty epic. Pretty cool, pretty amazing. And epoch is more something that my brain associates with time. Back in those days, that epoch, diese Epoche in my German head, that epoch of time when the dinosaurs were around and stuff. That's the epoch we live in. Anyway, what am I talking about? I'm shilling Klanos. Yeah, so I'm gonna say epoch. But just so you know, if somebody says epic, they probably mean the exact same thing. And you can debate me below that I should say epic as well. For now, I say epoch. Epoch, epoch, epoch. Epic, epic, epic. Epic is easier to say, but I'm still gonna say epoch. The more I say it, the more it sounds like a disease. Okay, anyway, so we can get the epoch. Oh god, that sounds like I'm getting sick. We're in epic, I mean epoch. See, if I say epic, then I write it wrong as well. So I'm gonna say epoch, because epic I write like this. And from the clock we get the epoch. Epic. What does Google say? Epic. You say epic. Epoch. There we go. It's British and American English. Cool. Okay. I'm gonna be British then. Can I have my cup of tea? Never mind. Back to me saying epoch. Epoch. Okay. So the epoch we're in is, let's find out. Test it. Show it. This is so nice and quick. I love Solana. We're in this slot and we're in this epoch. 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 Yes, I'm gonna completely make fun of this word until nobody can hear it anymore. Perfect. We also saw that at the cluster data. On mainnet we're on 505. On devnet 567. Nice. Epoch. In case you don't know what an epoch is, it's basically the time where one leader schedule is valid. So on Solana we basically divide time into epochs, epics, whatever. And for one epic, we define, in the first slot, this validator will be the leader. And the second slot, this validator will be the leader. And being the leader means he's allowed to produce the block. So we have the slots within the epoch. Damn it, stay consistent. Let's see if we find more detail. So epic is defined as the number of slots for which a leader schedule is valid. And again, Solana is not thinking in actual time, like milliseconds. Solana is thinking or performing or whatever you want to say in slots. And an epoch is just a number of slots. And whenever those slots are over, the blocks are built, then the epoch ends. Maybe I do want to say epic. It is actually nicer to say. Maybe I switch. What you learn in this video, how to pronounce epic. That's why there is no exact time for an epic, but the time is measured in slots. So that's the epoch epic. That's the epic epoch. Now before we get to timestamps, there's one more field, the leader schedule epic, which is the most recent epoch. Please be anything but consistent, for which the leader schedule has already been generated. Let's just have a look at that and then try to leader schedule. What would I expect it to be actually? I would expect it to be my current epoch plus 1. Yeah, current epoch plus 1. That makes sense. So we're in this epoch. And the leader schedule for the next epoch has already been created. So it could be that at the end of the epoch, it would be already another one created. But I don't know when the leader schedule is created. So basically, we know that for the next epoch, the leader schedule is already available. It could be that it's just available for the current slot. And for the next one, we don't know the leader schedule yet. And this stuff is hard to test because an epoch is quite long. Actually, probably a good point to really name it. How long is an epoch? How many slots are in an epoch? I don't know that by heart, but I think it's like a few days. There, 432,000 slots, which is about 2 days. Because 432 with a block time of about 400 milliseconds divided by 3, 48 hours. Ha! Wait, I know where my problem was in the previous calculation. That's hours and that's 2 days. Probably that's why this number, because it seems quite arbitrary, but it gets to exactly 2 days when we would have exactly 400 millisecond slot times. In reality, our slot times vary. Here we're even a bit faster than the 400 milliseconds. So the epoch is a bit less than 2 days. But overall, the aim is to get to 2 days. So that's why this number of slots. Good to know. And now that I found my issue, we can calculate how many years the definite cluster has been alive, because I was missing the divided by 24 hours. There we go. 3.1 years. That makes more sense. Thank you. Okay, so a bit more than 3 years. It's now September 2023. So yeah, in 2020, the definite cluster was started. Didn't mainnet start in May 2020? So pretty much after the big crash. Mainnet also has a bit longer slot times, at least currently, to 18 million times 400 milliseconds divided by 1000 divided by 3600 divided by 24 divided by 365 is 2.7 years approximately. Yeah, that. But really, it's the slot time that is probably a bit longer. So that's why it's more than 2.7 years and also over 3 years already. Because we started, if I remember correctly, we started in March 2020 even. I always confuse those 2 months. Yeah, in March was the big crash. That's true. Solana history. Anyway, rounded up 3 years is correct. Good, back to our program. Let's learn some more. Those were slot, epoch, and leader schedule epoch. Now there's those timestamps. Let's discuss those first before we go into what you should use when. Because as I said, Solana keeps time basically with their slots. And they might vary in actual time, like human time, like milliseconds time. Each slot has an estimated duration based on proof of history. In reality, the slots may elapse faster or slower than this estimate. Yes, I would say or here for language reasons, not for logical reasons. The slot can't be faster and slower than the estimate, so I would say or. But they say slots. Multiple, one can be slower, one can be faster. So anyway, so as a result, the Unix timestamp of a slot is generated based on an oracle input from voting validators. So essentially, the validators hold the actual Unix timestamp, so they know for them which time it is, real time. And then basically, they perform a calculation of the median based on the stake weight provided by the voters. So the validators that vote bounded by the expected time elapsed since the start of the epoch, which we also have here. It can't suddenly be like 10 days ahead of the epoch start time when we're still in the same epoch. I don't know what the exact bounds are, but it's bound somehow. So more explicitly, for each slot, the most recent vote timestamp provided by each validator is used to generate a timestamp estimate for the current slot. The elapsed slots since the vote timestamp are assumed to be nanoseconds per slot. Bank nanoseconds per slot. Oh, there we have the exact calculation. Each timestamp is allowed to deviate up to 25% from the estimated time since the start of the epoch. So a maximum of 2.5 days then away from the start of the epoch for the last slot. How I understand it now. And I didn't try. Yeah, you can read up on the details here. I don't think it's that important. Let's continue here. The important point here is just that the medium timestamp of those timestamps that the validators provide is then used for the Unix timestamp and is bound by those 25% away from the epoch start timestamp. So in the first slot of an epoch, this epoch start time is set to the Unix timestamp, whatever that timestamp is by then, just carried over from the previous one, which is also just the median from the previous votes. But then that is fixed, and then for the rest of the epoch, this timestamp is bound by a 25% error margin from this timestamp and the expected time that one epoch should last, which is 400 milliseconds. I'm pretty sure that's what's in there. Yeah, so basically what I want you to take away from this is Solana doesn't have a strict timestamp because it's a distributed system. There are several validators who might run at different times, like different local times. The timestamp we're using here is just a median. You can think of it as the average time, but it's not really the average because if there's a big outlier, it would drag the average too much. So we take the median, which is the middlest time. But if median doesn't ring a bell, it's basically the average time from the validators. From all the validators that voted, we take the time and take basically the middle value. And with that value, we actually work. Now, is that always the actual time, the actual Unix timestamp? Well, no, it is not. Most of the time it is very, very close, but it can be a bit off. But before we get there, let's actually look at it. Let's actually see how far we're off. I don't think that currently, when the system is stable, we're that far off. There's no attack happening. Current time is the Unix timestamp. Epoch started at the epoch start time. While this deploys, let's check out the format of this. It's a Unix timestamp, but what is that really? It's an I64, so it's a signed integer in Unix time, i.e. seconds since Unix epoch. Seconds? Okay. So we have the timestamp in seconds, not in milliseconds. I'm used to timestamps being milliseconds, but doing it in seconds is probably better anyway because it's just an average. And also within the same slot, this Unix timestamp is always the same. So it's the same timestamp for the entire slot, and the slot, takes 400 milliseconds. So actually it makes perfect sense that this is just in seconds because, we have like 400 milliseconds of time here. So yeah. So actually if it's in seconds, then it's gonna be pretty accurate, I assume. Oh, and by the way, if Unix timestamp doesn't ring a bell to you, because for me it does, but I had studied computer science, Unix time is basically the time that has passed since the 1st of January of 1970. That's where the 0 for Unix time is, 1970. And so this timestamp will be the number of seconds since 1st of January 1970. Unix epoch on January 1st, 1970 at UTC. That's Unix time. And that's just a standard way to work with timestamps in computers. Because again, we said in other videos, computers like to work with numbers, and having a certain number of milliseconds or even microseconds since the 1st of January 1970 just gives us a clear value to compare. So we don't need to work with years and whatever, right? So it's just one number, one large, but one number. Okay, so we deployed this. Let's clock time and see what the current time is. For me, it's 12:15 on the 19th of September, and I get this current time and this epoch starting time. So just to see if we're in the ballpark of what I expect. So this is the number. For some reason, this is German and it puts the dots. I'm pretty annoyed by that anyway. Let's just do this and pretend those points don't exist. 1.69 billion seconds divided by 3600 divided by 24 divided by 365.25 if you want to be even closer. So that's 53 point something years. That's pretty much what we would expect, because 50 years ago was 1973, 53 years ago was 1970, and we're in September, so that also checks out. Cool. And if we want to get it exact, so that's the current time, and the time it had then was 10:14, which in my time zone is 12:14, because I'm GMT +2. Checks out. If the cluster is running stable, then those timestamps are pretty accurate, but they are less safe to use than, let's say, the slots directly. Let me give you an example. Back in the days when mainnet had some issues, I remember I was bidding for domains, you know, those Bonfida IDs, the .sol domains. And back in the days, they were auctioned. You couldn't just buy them, but there was a 7-day auction. And whenever a new bid comes in, then the auction time was prolonged. But right after the restart of the Solana cluster, the Unix timestamps weren't like correct. And so this was super buggy and auctions just ended right away, or other really weird behavior happened because they were using these Unix timestamps, which are a convenient way. Like timestamps, that's something we as humans understand easily, right? It's nice, I can work with seconds directly, so I can be like working with minutes, working with hours, working with days. It's just a calculation on the timestamp, but then you trust that the timestamp is actually correct, which in most of the cases you can do. However, if it's something really security critical, I would suggest that you work with slots, like we have seen in, was it at the lookup tables? I think it was at the lookup tables, where we built the account lookup tables, and before we can close a lookup table, we need to deactivate it and wait a certain number of slots. And a certain number of slots corresponded to the number in the recent slot hashes. So yeah, working with slots gives you the advantage that it's, for Solana, pretty clear that it can only go up in time, right? Because the next slot will always be bigger than the previous slot. With the Unix timestamp, in really rare edge cases, it could happen that a higher slot actually has a lower timestamp than before. As long as it's within the 25% range, like if enough validators with enough stake weight push the time up and then push the time down, they could theoretically influence the actual Unix timestamp. So if you're doing some comparisons, especially on the range of seconds, like if you just compare, oh, this Unix timestamp must be smaller than this other Unix timestamp, which could happen in the next slot already, that's not super secure from my perspective. Also, when the cluster just restarts, the Unix timestamp can be pretty much very inaccurate or even completely wrong. Do I expect the cluster to ever restart again? No. And it could happen. You don't know. So yeah, my point here is whenever your application can use the slots for convenience, so if you just do some checking, this event must happen before this event, then work with slots. Check that this is happening in a slot and compare the slots. Don't compare the timestamp. The timestamp I would only use for something like, yeah, I lock something up for X amount of months or years or even days, okay? Because there I could also use the slots, but that's not so accurate, especially when it goes to like far into the future. I would use Unix timestamp because slots are just not that exact. And users probably want to have the exact 24 hours and not the approximate 24 hours. But yeah, that's the difference. So for comparing events, I would use slots. For something with actual time, especially on longer time frames, like anything over a day, I would use the Unix timestamps. But for stuff like locking something up for, say, 10 seconds or so, just to make sure that some kind of attack can't be performed, I would still use slots. Because the slower the time frame, the less secure this Unix timestamp actually is. Because it can vary a bit. I'm not saying it does. For probably 99% of the slots, this is super accurate and you get the exact second that we're actually in, plus minus 1. But it can happen, of course, that the Unix timestamp diverts a bit further. And since this is just something that is coming from an oracle, so from the validators. Basically, they calculate it based on their time. That opens you up for attacks. I wouldn't expect that to be exact. Yeah, so that's my suggestion for working with those. We now know how we can work with those. Just access them. And this, again, this is a signed integer. Those are unsigned integers. All of them with 64 bits. So 4 bytes. No, 8 bytes. And obviously, if you display it like that, you might want to calculate the actual time like for a user. But my recommendation is don't do it on chain. On chain, you don't need to know what the actual year and whatnot is. I mean, you can work with timestamps directly and compare them and set a target timestamp, but also store it as a timestamp, not as a year or whatever. Never do the conversion, always just work with the timestamps directly. And then in the front end, you can convert the actual timestamp to a human readable date. Because if we do it on chain, then we just burn compute units, which is pretty much useless. We need our compute units for something more important most of the time. Yeah. Do you want me to build a quick example, or is that good enough? Okay, let's do a quick example. Let's build ourselves an instruction that can only be called once per slot. So we'll need some slot account tracker, which basically just stores my last slot when that instruction was called. And remember, slots are just U64s. So we need 8 plus 8 is 16 bytes. Doesn't really matter, just so we have a PDA. And then basically the same thing, so the same seeds, but just mutable, don't init it anymore, for my once per slot instruction. So this once per slot instruction then just does the following. It gets the clock, as we did above, gets the clock, and then compares if last slot is smaller than the current slot that we have in the clock. So this must be the case. And actually, the nicer way to program this is to invert it and throw an error if it's not the case. So if the last slot is larger or equal than the current slot, then we throw an error. Here we then just do the stuff. And important not to forget, we then also need to write the slot. Say here the last slot is now the current slot, such that next time when the instruction is called, this check is performed on that slot. Okay, so let's build this and deploy this. All right, so I need to first init, so just create that account. That account from seed, what did I call it? Slot, just from a static seed slot. There you go. Signer is going to be my address and system program. Perfect. Let's do it. So that account is created. That's all it does. We can ignore it. Now to the interesting part. Here we again provide the same account. This just tracks the slots. So that's my slot tracker account. And now we call this once per slot instruction. Call it once. Perfect. Works. We can do stuff here in this slot. And I can do it again. That will also work. And I can do it again. That will also work. And again. But then when I do it twice in the same slot, because it's confirming and then I can't click fast enough. Oh, damn you. I want to send that faster. That's annoying. Well, fine. Then I change my program to it needs to be valid for 10 slots. So it's now a once per 10 slots. Just add 10 here. The last slot plus 10 must still be smaller than the current slot. Otherwise, I error. The alternative, how to write this nicer, instead of storing the last slot, I could just store the next allowed slot. Then not do the calculation here, but set the next allowed slot to the current slot plus 10. That's actually nicer. So we now have to wait 4 seconds approximately. So only every 4 seconds are we allowed to call this instruction for whatever reason we might want to do that. All right, let's go. So once per 10 slots with that PDA. Let's test it once, should go through. But if I then send the same thing quite shortly after, this one fails. Error processing instruction 0. It doesn't give me the, also can't really show properly. But if I wait a bit more, it works again. And then no. Man, can you show me like more? Also I mean, Playground is nice to get started, but really you probably want to work locally. Yeah, but so essentially, I mean, you get it. You get it what's happening here, right? We get this invalid slot error. Only one instruction call per 10 slots allowed. That's instruction 0 that errors like this because we didn't wait long enough. So that could be one use case, one way how we deal with that. Clock. And in a similar fashion, you could do a lock and unlock thing. You create yourself a vault, unlock, timestamp, make it a I64, and whatever else you would store in your vault. Lock. But here we would actually also put in the signer key. It's a reference such that every signer can create a vault or something like that. That's for the lock, and then for the unlock. And of course you would add an authority that is allowed to unlock that, because otherwise everybody can unlock it. We're just focusing on the time part now, not on the... And then we create our 2 instructions, lock and unlock. Lock basically creates this account, and then it needs to write into the vault account unlock timestamp the time when the vault is allowed to be opened. So we could here do something static or put it in as an instruction, something like lock seconds, and we'll again work with the clock, just get without providing it as an account. From the clock we get the Unix timestamp, and we add, because this is in seconds, then we add how many seconds we still want to lock it. Until then it's locked, and this again for the user could be passed in the front end nicely. And then the unlock, here we again need to take care that if clock, so the current time is not yet the unlock time, and here the 1 second, I don't, if it's exactly that second, I allow it. If it's smaller, then I also error. Unlock time not reached. And otherwise, vault unlocked. Whatever that actually means then. You know, here I would then actually do whatever with the vault. Also, remember to do some signer checks. Check that whoever unlocks this actually is allowed to unlock this. But I leave that out for here, for this example. It's just a time example. So it's just that if the time is not the unlock time yet, then I error. Otherwise, my vault gets unlocked. So let's also do this. See if that builds. No, it does not. Why not? Because I can't. Okay, fine. I'm gonna let you work with signed integers. I would then probably check that that's an actual positive number, and you know I need to check bounds. Or actually I don't. In Anchor they are checked automatically. I learned that recently, that Anchor, if there's a overflow or underflow, Anchor automatically fails. So yeah, it's up to the user to put in the... If they lock it for 0 seconds or negative seconds, well, then it's like they lock it for 0 seconds. It's their problem then. I don't know why they have signed integers for timestamps. I don't really get it, but it's whatever. It's fine. I would use unsigned for those kind of things. You don't want to go back behind 1970 anyway. Deployment successful. So let's try it out. Let's lock ourselves something for, I don't know, 60 seconds. Vault and my public key. Generate. This is the vault account. I'll be the signer. Test. Cool. Can I unlock it? Nope, I cannot. Unlock failed. It fails because obviously it's still locked until something, but it doesn't properly show me that because Playground doesn't do a nice job here. I mean, at least the error name would be nice. So let's wait a minute. And then it passes. Amazing. That's how you do an easy lock and unlock based on time. Again, for non-security critical things, you can work with the Unix timestamp, right? If you want to lock it up for 10 seconds here, do it. 60 seconds, do it. As long as it doesn't matter that those 10 seconds might then only be 5 seconds or might even be 0 seconds. If you're okay with that, then you're fine using it like this. If it would be something security critical, and also if you're just trying to do something like this needs to happen after something else has happened, I would suggest using either increments of random numbers, or going with the slots. But yeah, I hope that this gives you an idea of how to work with the Solana clock, Sysvar, and Sysvars in general. Hope you understand what they are now. So yeah, I think we're gonna wrap up here. Thank you for watching this Solana tutorial. Check the time again. It's time to end it. And watch another video, one of these. Also, don't forget to like and subscribe. Yeah, if you have any questions about Sysvars or the clock Sysvar or anything that I told you about, ask them either below in my Discord, on Twitter, or on Solarplex. I'm on Solarplex. You want an invite code? Let me know. Yeah, okay, good. Let's not prolong this video and just say goodbye. Bye-bye.